Welcome to the Claus YouTube channel.
Together, we strive for a safer, secure, and more stable world.
Good evening, everyone. Welcome to yet another episode of Claus YouTube channel, The Strategic Frontlines. Today, we have with us Air Commodore Dr. Ashminder Bhal, VM retired, and we will be discussing breaking new frontiers in space. Welcome, Air Commodore Bhal, to this
Thank you,
episode.
ma'am. It's a great honor to be on Claus YouTube channel, one of the greatest think tanks that I've ever been associated with.
Thank you so much. And finally, after 41 years, we will see another Indian astronaut, Group Captain Subhanshu Shukla, who will undertake the space voyage to the International Space Station. And he is going to aboard the SpaceX Crew Dragon spacecraft atop a Falcon 9 rocket as a part of Axiom Mission 4. And this mission is headed by a lady US commander, Peggy Whitson, and who was the chief astronaut for NASA before she retired. And she has the record for most cumulative time in space. I think it was 665 days. And we will also see, after a very long time, representatives from two countries, Poland and Hungary, namely Mr. Uznansky and Tibor Kapoor, respectively, who will be taking this voyage. And the good news is that Group Captain Subhanshu Shukla has been selected as the pilot for the Axiom Mission 4. And this private space flight is possible because of the collaboration between NASA, SpaceX, Axiom Space, and of course ISRO. So I think they're going to stay there for 2 weeks. And Air Commodore Bhal, it has been a long wait, because it was only in 1984 that Rakesh Sharma, when he flew aboard Soyuz T-11 as a part of Russian Intercosmos program, which was an India-Russia joint collaboration. And he spent, I think, about 8 days in Salyut 7 space station. So I would like to ask you first, what is the difference between these two missions, apart from that was the Russian one and this is the US one? And secondly, how complex is the procedure, especially the docking, as also if you could also highlight a little bit about the International Space Station.
Absolutely, ma'am. You'll be surprised to know that there are either 7 Indians or Indian origin people who have gone to space. And the first one was Rakesh Sharma in 1984, like you rightly said, on Soyuz T-11. So he did that. He stayed 3 days, if I remember right, or 8 days, like you say. And thereafter, so many years, 41 years. But in between, we hear a lot of names of our own, Kalpana Chawla, Sunita Williams, Hari, and there was a space tourist also who was an Indian, and 2 engineers who went with NASA. So they were all who went and who stayed, but they were not Indian astronauts. This is the first Indian astronaut who's going to stay in International Space Station. Now you were asking me what is the difference. No, International Space Station, why do we require it? It's like a huge laboratory in space. It is orbiting at an altitude of 400 kilometers, and it takes 93 minutes to complete one orbit, and it is traveling at 28,807 kilometers an hour. So you can imagine how complex it would be when there is an orbit being carried out by a satellite, by a space station, and you have a rocket, Falcon 9, which releases the module, and that module has to come and link up. Whilst they are in orbit traveling at that speed, you cannot make even a single mistake of a few millimeters. So we are looking at a space where there is microgravity. And microgravity is what? Everybody thinks microgravity means there is no gravity there. There is actually a gravity. But remember, there is no atmosphere. So if there is a body traveling, it will continue to travel at that same speed. And also there is a gravity acting. So now the body doesn't come back to earth but travels like this. With the
Yes.
result, what happens, you get a feeling of weightlessness. It's an illusion, but that's why it's called microgravity. So means you feel you are weightless but you are actually falling in a free fall. And that is why they're in relation to other objects, you are actually stationary. Now this has to
So,
be trained.
how much training is required in this? Because a lot of
Exactly.
training must be required for that.
Absolutely. So not just look at the complexity. I'll come to the complexity even more. This is just one aspect. When the Falcon 9, it's got 9 engines. That's why it's called Falcon 9.
That
It has 2 stages. So when the rocket takes off, it continues to accelerate and goes supersonic, hypersonic, and thereafter, when it comes to the second stage, its speed goes to 33,512 kilometers an hour.
Wow,
Can you
that's too
believe
much.
that? That
Yes.
is too much. And on top
Yes.
portion is the module, which is the Dragon capsule. And in this, there are normally 7 seating places, but they normally take about 4. And in this, when they sit down on the chair is movable. It goes back, and they are now like this because of the high g's that are associated with this acceleration. It can go up to 6.5 g and negative up to 2.5 g, and that is why they need to be more like in lying down position on the chair itself. And in front of them are 3 digital screens which they can operate for their maneuvering subsequently. So when and the module is on top of the rocket. So now first stage, when it moves out, it releases, it is actually reusable. It goes back to earth. And when it
Yeah.
goes to earth, there is a platform which is unmanned, which is kept on the ocean, where it comes and lands. It is a very precise maneuver for the stage one. That's why it's called a reusable rocket. Then
Yeah.
stage two is not reusable. You cannot use it again. So the stage two accelerates, reaches those maximum speeds, reaches the altitude of 400 kilometers, and now releases the Dragon capsule. So when it releases the capsule has 16 Draco thrusters. What it means is that each thruster is like a small engine which is producing 90 pounds of thrust, and it is moving it in all directions so that it comes directly below the space station at 400 meters. This is waypoint 1. From this waypoint 1, it goes to 200 meters, 220 meters in line behind a stern position of the space station, flying at the same speed and slightly more than the space station. And the speed is reduced to 10 meters per second. 9.3 kilometers per second was the speed, if you remember, when they achieved maximum. Now it is reduced to 10 meters, then to 1 meter, then to 0.1 meter per second when they reach 5 meters of distance, which is the distance where the crew hands over control to autonomous. Now there is a port, which is the docking port. In that docking port, this maneuvers and autonomously keeps coming ahead and then puts in for a soft arrestor. And after this, there is a hard, catch in which 12 of the locks come on to the capsule. And thereafter, air lock takes place. First, the Dragon capsule hatch is open, the pilots come out, and then the hatch of the space station is open, and then they cross over and get into the space station. See how accurate maneuvering and so difficult. And remember, outside, this is at thermosphere. At mesosphere,
Yes.
when you are going up, the temperatures are dropping till they reach minus 85 degrees centigrade. But in
Yes.
thermosphere, inversion takes place, and now temperatures are increasing, and they
Increase.
increase to 2000 degrees centigrade. And when they increase to this temperature, is what is going to be felt around 400-500 kilometers of altitude. There is solar wind. Solar wind is what? There is a
Yes.
wind which has protons and electrons which are in a continuous flow. Then there is vacuum. Then there is many other things besides the solar wind, such as subatomic particles. All these make it extremely difficult for the docking and also for a person who's going in from one capsule to the space station. So you can imagine how intricate this operation must be.
So much complex maneuvering taking place. And once you get docked, then your actual mission starts when you start doing all the experiments, what you're supposed to do. And if you can throw a little bit of light on those also, that what are the
Absolutely.
experiments which these people will
Yeah.
be doing. And
Now, first of all, there are 60 experiments they are doing. And for that, they are trained on ground. You had asked me this question also. What is the type of training? Incidentally, this group captain Shukla was born exactly 1 year after Rakesh Sharma had done
oh,
that flight, space flight. He had done it in 1984. He was born in 1985. And in 2005, he completed his NDA. Thereafter, 2006 June, he became a fighter pilot. And in that, he had already attained a degree of, expertise in flying fighter aircraft, which he flew as Su-30 MKI, MiG-29, MiG-21, Jaguar, as well as transport aircraft like AN-32s. And he was also a fighter combat leader. In He did computer science in NDA, but he did masters in technology from Indian Institute of Sciences, Bangalore. This guy is a highly read person. He's physically fit also. You see his pictures; he's
yes,
absolutely fit, and that's a
yes.
great thing. Looking at him, and
Yes, you
yeah,
have to
so
be physically fit, because if you're going to undertake such a difficult task, you have to be physically, mentally, both
mentally.
very, and your reactions have to be very quick.
Dr. Roshan, you're absolutely right. So that's why in 2019, they first undergo tests at IAM, which is Institute of Aerospace Medicine. Most of us fighter pilots had gone there and we undertook the high G test, and some of us blacked out. Thank God I didn't, but some of us black out because of the high G that effect comes in. So it is checking physical fitness, like you said, it is checking mental alertness, like you said. These are the
Yes,
two things. Then he was shortlisted, and
yes,
after that, this is not the first stage. After this, he went for training in Yuri Gagarin Cosmonaut Center, which is in Russia. And there he was given all the basic cosmonaut training. And thereafter, he did advanced training in Bangalore in the astronaut training facility. What is the type of training he does, and that helps him in this experiments. And that's why I'm linking it up. Besides the classroom training of all the experiments and other things that he will carry out, 60 of them, his physical fitness training, simulator training of how he's going to do what all activities inside and both in docking as well as inside the station, that is ISS. Then microgravity familiarization, aeromedical training, survival training. In fact, they are also made to do yoga, so that they remain mentally absolutely calm if there is any emergency that takes place. Now, after this training, he went and got trained in ESA in Germany, and he was also trained at NASA. It's not one day. See, his training started just post 2019, and it is 2025, and he's going tomorrow for the space launch. It's over 6 years that he's been
yes.
continuously training
It's a
for this.
continuous process, and you have to be very fit mentally, physically. It's a long process.
It's a long process. And then what do? You're going to study solar storms. You're going to study biological effects at that altitude and in space. You're going to study solar winds. You're going to study high temperatures, microgravity, and you're going to study what are the effects of various components and parts in that environment at that altitude of space. And it is not easy. One of the functions of ISS is also that the spacecraft that are being built, their subcomponents and components are first tested here, so that when they are proven here, then you can go to Mars and you go to Moon or long or intergalactic operations or wherever you want to go. So this is very important, this space station, and its life is only up to 2030. By 2028, Russia will move out. There are 15 countries in it right now, which includes the US, Canada, Japan, and 11 of them from ESA, that is European Space Agency, which are the European countries. So total about 15. Russia will move out in 2028. Life of this is 2030. and then it will be deorbited. So I've just given you a gist of how they will be trained, what are the type of experiments they will carry out, and what is the complexities in docking and how they're going to stay over there.
Yeah, but continuing with what you stated, that we know that ISRO has been quite successful in its endeavors in the past. For example, if we see the first satellite Aryabhat came in 1975, and from there to having set a world record in 2017 by launching 104 satellites in a single mission was quite commendable. And we also have a lot of missions which have taken place, whether it was mission Mangalyaan or the Chandrayaan series. And we know that in the Chandrayaan 3, we achieved the soft landing near the moon's south pole. Then there was Aditya to study the sun. Now we are planning to have an indigenous human space flight mission Gaganyaan, which I think will happen by 2027, and I think 4 astronauts have been selected for it. So I wanted to ask you how this mission of
Yeah,
Group Captain Shukla going to help the Gaganyaan mission. Are
very
there
nice, ma'am.
any takeaways from that which we were going to involve here? And those astronauts who are training, are they training in India? Have we got the facility to train them? How is it planned and how is it developing?
Very nice question, ma'am. Because now we are looking at the future, and why Group Captain Shukla will be one of the members of that team which will do the human flight, and what are the intricacies there, and how is he? No, this particular mission, though the mission commander is Peggy Whitson, and you like rightly so said, she's very experienced, and the mission pilot is Group Captain Shukla. And the other two gentlemen from Poland and Hungary, they are mission specialists, dealing with various missions. But this is the time that he's learning from all of them. Because in all probability, he will then become the mission commander for Gaganyaan when it comes up in 2027. And he's already learned everything. Learned from ESA, learned from NASA, learned from the Russians, learned from our own Bangalore facility. And like you rightly said, that we also have astronaut training facility at Bangalore. And in that, they will be doing all this. The other two members, it's going to be a 3-member crew as of now. It can change later on also, but at least 3-member crew. But you do not launch a Gaganyaan immediately. The Gaganyaan is not launched without having various tests that they carry out before that. This project was started some years back when we looked at how do we send a human being in space, because we don't have a space station. So what is going to happen is that even though we don't have a space station, but we will take them to space, we will make them orbit, and we have to recover them in Indian Ocean or in the seas close to us. So this is the overall project, and this project, the group captain Shukla may be the mission commander, but the problem is not this. The first is that there will be numerous tests carried out. The tests carried out on ground, just taking it up and leaving those modules to come down to see whether they can withstand. Then testing them in space. So there will be an uncrewed mission which will be flown in 2025 this year towards the end, or maybe early next year if such things do get, because of weather changed a few days here or there. So uncrewed mission. Uncrewed means without a man, and they have chosen the vehicle, launch vehicle. Like we had Falcon 9 over there, the launch vehicle in this is human rated launch vehicle Mark 3, which is about 53 meters tall. It is 640 tons. It is already being made. It has 3 stages, unlike the Falcon 9, which has 2 stages, and it can carry 10 tons of payload, which means 10 tons of the module it can carry. Now, they also have a beautiful thing, our own human rated launch vehicle. On the top portion is where the crew module and the service module will be, like this. And on top of that will be an emergency system, that is crew emergency system. In case they face a problem, this will move off. And this entire crew module as well as service module and the crew emergency system forms the top part of the rocket. So the first stage will go second, and towards the end only this module will be the one which will be orbiting the space, and then it will be recovered on Indian seas. The problem always occurs is that they will be carrying it out to check if there is going to be any emergencies in the uncrewed one. So they will be carrying dummies, and they will also be having the similar weight as human beings. Very interesting thing, Dr. Roshan. These seats are designed as per the pilot. They are the same size, shape, height, weight. So they design the seats so that when they go back and lie, they are absolutely comfortable, and they can bear those loads of plus G and minus G that come up. And the main thing with this is it is going to be put at 400 kilometers of it. Something very similar to the space station.
Yes.
And
So
ma'am, the
it's
actual thing is that we are going to have our own space station by 2035.
Yes, actually, the end thing is that only we should have our own space station, and that is, I think, a Bhartiya Antariksh station. What we'll have it, that would be wonderful once we have it. And uh, to go ahead, I would just like to digress a little bit. I mean, we have been talking about space stations. Um, when we were young, we used to see Star Wars, and you also know Captain Spock, and there were so many of them who were very
I
popular
love
at
the
that
shows.
time.
I love
Yes,
the show.
yes. And so I wanted to ask you, is it possible in the future the militarization or the weaponization of these space stations?
That's
Can this
that's
space station be targeted? Because military personnel and military technologies, they all are being used for research and operational purposes. And if we consider that the Outer Space Treaty, it prohibits only the WMD, that is the nuclear weapons in space, and does not talk anything about the conventional weapons. So there is a kind of a gray area there. So my question is, not now, but we know that all the countries, like major countries like US, Russia, China, all of them are doing a lot in terms of militarizing the space. We know a lot of activities are taking place as far as satellites and orbital things are concerned. We know anti-satellite weapons are being created. A lot of rendezvous is being done by the Chinese. So those things are doing. But is it possible to weaponize the space station, and especially if there is political restraint in future, if it gets weakened and there is more competition amongst the major powers? So what is your view on that?
I think it's a very tricky question. Whichever way I answer this question is going to have repercussions. So, first thing is, Dr. Roshan, I congratulate you because this is an extremely important and a vital issue. Second thing is, you're seeing what is the developments taking place in missiles today. Their speeds are increasing to hypersonic speeds, 10 Mach, Oceanic, which created havoc in Ukraine. So I'll take a few minutes and build this background so that we have very clear picture whether weaponization will take place or not. Now, the second thing that comes in, what is the ICBM RS-28 Sarmat of Russia? It has a range of 15 to 18,000 kilometers. No part of Earth is safe. It has, a MIRV system, that is multiple independently targetable re-entry vehicles.
Re-entry
There are,
vehicles, yes.
yeah, 15 warheads it can carry, and each of this warhead could be like an avant-garde glide vehicle. Avant-garde glide vehicle travels at a speed of 27 Mach. And this is coming virtually, this weapon system comes from exosphere. And there is no counter today for this. Leave
Yes.
aside, there is no counter for Orishnik. There is no counter for Sarmat, which is going even way beyond ahead. Now, when we are looking at that kind of systems, you have to have defenses. And that defenses may not be only be based at Earth, because these weapon systems could be carrying nuclear missiles, nuclear weapons. And if they carry nuclear weapons, and you cannot differentiate between a missile that is carrying a nuclear weapon and a missile that is carrying a conventional warhead. And that is the reason why Trump has come out with a golden dome. Golden Dome means that he's going to have air defense systems also placed in space. He's not talking of it, they are not mentioning it. But then, how are they going to tackle a weapon system that is coming in exosphere? and is not yet being tackled by any weapon system. So when it comes from exosphere, it is going to go down, release its MRFs, and they will travel at 27 Mach. There is no way anybody can intercept them. So it's not just endosphere. We are talking of interception at exosphere, and that is what the main aim of Golden Dome is. So this means they'll be keeping weapons over there. You rightly said, Outer Space Treaty of 1967 states that nuclear weapons will not be deployed in space. So they're not going to deploy nuclear weapons. But there are already methodologies found by the Chinese where they have co-orbital satellites. So they
Yes.
can come and impact at you. Or they have
Yes.
directed energy weapons, which includes both electronic warfare abilities as well as energy lasers. And right now, last year, the Chinese claimed that they have developed a cooling system where they can use a very high powered, high energy laser. And those can kill satellites in low Earth orbit as well as in high Earth orbit. There will be no choice left for anybody. Leave aside Russia, China, or US. It will not be there for us also. We would have to
Yes.
weaponize space. There is no
Yes.
choice. America is doing it by calling it Golden Dome. If they say they're going to tackle the weapon systems in exoatmosphere, they would have to position the weapon systems somewhere in space, which implies that best part is space platforms, that is space stations. But the problem that occurs is that the space station currently has 15 partners. So there is going to be restrictions. And these partners are both US, Russia, opposite sides of the NATO. Now, but when we have space stations like Tiangong, which China has, which is its own space station, be rest assured, there will be directed energy weapons, there will be high energy lasers, there will be weapon systems which they will eventually base, and it will happen in your and my lifetime, which means 2035. Before that, they are going to do that. So, answering your question in one sentence now to sum up everything that I said, if we do not work towards weaponizing space, the others will leave us behind.
Definitely what you said, and that is really a worry because weaponization of state space is not very far off. I mean, the amount of technological innovations and everything is taking place, and space is becoming a very important domain as far as we all are concerned. And now, moving away from that little bit, I just wanted to ask you one last question: is it when we talk about space, we need to ask about private and public partnership also, because a lot has been done by this government as far as the private sector is concerned and getting them involved in the space. I think about 1,000 crore venture capital fund has been given for the space startups, and the space sector reforms of 2020 has opened the door for private sector. And two initiative what I would like to talk about is in space, that is the Indian National Space Promotion and Authorization Center, as also the NSIL, New Space India Limited, has been formed. So would you like to show some light on these issues also, because after all private sector plays a very important role in our section.
Ma'am, one of the limitations which they said why China has gone ahead of us, but then China is an autocratic society, they can allot a large amount of funds. We can't do the same. We are a democratic society. We have to look after the interests of a common man also and development of the country also. For China, it's not of a major issue. For us, it is a major issue. So what happens is we were facing fund crunch earlier. Let me put it in perspective. Before 2020, one of the major constraints was funds, and major constraints was lack of private sector participation. But the government came out with beautiful initiatives. It came out in 2020 with space sector reforms, the ones that you were mentioning. The space sector policy came up in 2023. And earlier, we used to outsource components and subsystems and some structural parts of the satellites or of the launch vehicles. So we have moved away from this vendor business, and we have come now that we are focusing on three important aspects. The first is design of satellite vehicles. That itself is now the private sector is getting involved. Second is ground support systems or ground control stations or various other things on ground which support the entire space-based activities. There they are getting involved. Launch vehicle manufacturing. Actually, like SpaceX, if you see, when a very interesting story I'll tell you. When Sunita Williams got caught, she had gone for a few days. She eventually stayed 286 days in space. It was finally SpaceX which sent its module, which was C212. This one is 213, the one which
Yes.
Shukla is going.
213.
So it
Yes.
sent 212 Freedom to get her out. See, the name also they gave Freedom. So it was private sector, Elon Musk company, which
Percent.
sent its Falcon 9 along with this Dragon capsule C212 and Freedom, and that great person was brought back to Earth who was stuck there for 286 days. So unless private sector gets involved, and now NASA mostly outsources its tasks to SpaceX. So what we require is something like that, and the government has taken a lot of pains for this. I'll give you some more example. In space, you mentioned it acts not only as a regulatory body, but like you rightly said, it has got a financial support of 1,000 crore venture funding. Which is a very, very, very a positive step which the government has taken. And then we have Antriksh, which used to be earlier be the commercial arm. Now NSIL is the commercial arm, and
Yes.
Antriksh is supporting satellite launch of private, companies. That's a great move forward. And ISRO is giving away technologies. It's sharing its technologies, and NSIL assists in sharing of technologies, and even in space is assisting. Actually, it's a good thing. It's a combination that is working very fine. And the number of companies, let me give you some examples. 200 startups have taken place since
That's a
2020.
huge number.
That's a huge number. 2023 private sector invested 125, sorry, $12.5 billion in space. The total space economy is about 650 to $700 billion, because the figures I've got of 2023 state about 640 or $646 billion. So it must have gone up beyond that. And India's contribution was $8.4 billion. We are looking at a contribution of $44 billion by 2033-35, and
That's
I'm
very
positive we
heartening.
will do it. I'm
Yes.
positive we'll do it. The companies you in fact, when we were discussing earlier, you wanted me to give some examples. The Skyroot Aerospace, that's the one which was the one of the first ones. Then Dhruv Space was the first for modular soft satellite platform. Then Agnikul, which is working in small satellite launch vehicles. Bellatrix Aerospace in green propulsion systems. I mean, if I start telling you, my whole next 15-20 minutes will go in the list of the startups and the companies. But a very nice thing also has happened, about Defense Space Agency. And I must share that with you, because Defense Space Agency was approved by the Honorable Prime Minister in September 2018. So it was a very major step. Till then, we used to have space cell. एक छोटा सा cell होता था. Now we
Right.
have a defense space agency whose primary role is what? To develop a comprehensive space warfare strategy. And it's a huge thing
That's
because it's coming out with a space doctrine. It is coming out with space warfare strategies, both anti-satellite defense as well as, that is D-satellite, defense satellite, and anti-satellite warfare. It's going to make those strategies, and it's going to make processes and procedures to implement those strategies. That is the beautiful part.
that is
You
very
remember.
nice. I think that is keeping in tune with the multi-domain warfare which we are going to have, and in that the space is going to play a major role. So it's so heartening
Exactly.
to
And
hear that what you are saying.
yeah, exactly. And you're just supplementing exactly in a very nice thing. You said it's going to be a tri-service command: Army, Navy, Air Force. Eventually, it will become a space command, and it will have not just these doctrinal things. You remember an anti-satellite test which was carried out in March 2019, where we hit our own satellite at 283 kilometers altitude, and
Yes.
that entire operation took just 3 minutes from
Yes.
launch to destruction. So accurate by the kinetic kill vehicle. Now, all these functions will be done by DSA. And what else will be done by DSA? DSA is going to have DIPAC with it. That is Defense Imagery Center, Control Center, which is there in Delhi. Defense Imagery Processing and Analysis Center, DIPAC, which is in Delhi, as well as Defense Satellite Control Center, which is in Bhopal. They both have come under DSA. And DSA one day is going to be Space Command. And it is going to determine, like today we have 9 military satellites and we have NAV-1C, which is for mainly military and restricted use for positioning and navigation. They have 7 satellites in that, and we are going to increase it to 11. So we've got dedicated 9 satellites, and the number is going to be increased very soon. We have 52 satellites orbiting today, out of which 22 are in low Earth orbit. It makes me feel proud to be an Indian.
Yes.
Let me assure you. The
No,
future is going to be great.
And in the future, if we see the way the revolution in military affairs have taken place, the real-time information is the key. And the real-time information, in order to get it, is very essential that we have more satellites in space. Thank you so much for this thing. I think we'll take few questions, if you don't mind.
Yeah,
I'll just
absolutely.
highlight a few questions. This is from Alia M. She says, thoughts on a global treaty, regulatory, military use of space. Is that limiting? And if India pushes for it, will it be left out? Basically, like what happened in NPT, if we see. So it's something of that sort she's trying to say.
Yeah.
What are your views on that?
Absolutely. See, there are 2 major treaties for space as of this moment: Outer Space Treaty of 1967 and Anti-Ballistic Missile Treaty of 1972, which the US has walked out of it. So
Yes.
that is why when we were talking of weaponization of space, all these treaties have meaning till the time the powerful nations decide कि मेरे को तो attend करना नहीं है. So if they don't believe in it, do you think we can take a chance? So treaties are fine. Treaties like NPT must be respected, but at the same time, a country's defense comes first, always and every time.
That's what this VS is saying. He's saying that international treaties are pushed by developed countries only when it is in their interest, when they have more to lose than gain, if such treaty is not signed. Once they have a particular technology, they've mastered it, they don't want other countries to do, so they push for the treaty. That's what they're trying to say.
Absolutely, absolutely.
Another one is, Chinese are working with Russians for putting a nuclear reactor on its moon base for future by 2035. I mean, I don't think it's
that's interesting.
Now,
that's
yes,
interesting,
that's
but I
interesting.
really believe that this is in a realm of fiction as of this moment, because
Yes.
we do not have those kind of technologies to be able to have such reactors working in moon, which is going to have its own problems of gravity as well as own problems of atmosphere there. So I think this is right now in fictional stage. Maybe
Yes.
30, 40 years or 50 years from today, maybe this could prove true.
There is one also. Mr. Thadani is asking, given the suboptimal performance of enemy's Chinese weapon system during Op Sindoor, puts in doubt the progress these Chinese may have made in space technologies. Your views? It's a very valid point,
first of
because
all,
air defense system we have been talking about.
it's absolutely correct. So I'm very happy when we found the PL-15 missile lying on ground, and all the countries, US, UK, France, are after us. Please show that missile to us. So I'm very happy if their systems malfunction. In fact, even the Turkish systems, 4 drones of theirs, Yiha-3, fell in their own territory in Pakistan. We didn't do anything. We'll be happy if their systems keep falling off like this. But the point is not that. The point is, in space, Chinese have made real progress. You know, they have the largest number of satellite launches in a year. Anywhere from 55 to 70 launches they carry out every year annually. This is the largest in the world. They have the largest number of satellites. America has the largest number of satellites overall.
Second largest is theirs, yes.
Second largest is there, but they've got the largest number in South China Sea, in Pacific, as well as in Indian Ocean region. So they are progressing very fast. I remember the decade, which was the early part of 21st century, when Chinese asked us to cooperate on satellites. But today they have gone ahead and they got their own space station. So Chinese are progressing well in space, directed energy weapons, and laser weapons.
Absolutely, what you're saying is right. And even in the orbital areas, they are doing very good. They have the robotic arm which can catch the satellite in space. So those are the areas which they are progressing very fast. And space is especially the area which they are going very fast. And they are going to have in the Leo also a lot of satellites which they have planned, which they are going to do within a span of 4 to 5 years. So
Absolutely.
I think they are going to do a lot.
and
Uh,
and China is also doing very well in cyber warfare. If you remember that Mumbai power outage in October 2020 was caused by a malware that they had put into the servers of the distribution center of Maharashtra State Electricity Board. So this cyber technology also they are developing very well. Directed energy weapons they are developing very well. High energy lasers they are developing very well. Space technology they have advanced quite a lot.
yeah, there's another question, and it collaborates what you have been saying. That what's the potential of Chinese weapon in space? I heard they have the largest satellite fleet in the space. So
Yeah, I think
just
I've
trying to
already
say that.
answered that question, but
Yes,
I'll just say one line to it is that we must never underestimate the enemy and we must
yes,
never underestimate their capability. And India needs to do enough both for defense satellite as well as ASAT capabilities. And we need to do it today and not wait for tomorrow to come.
yes. We have already demonstrated the A-site capabilities. We are also developing hypersonic vehicles, but I think we need to do it at a little faster pace
Pace.
so that we have the
Absolutely.
uh, what you call assets when we require. But
Absolutely.
we did very well as far as the Op Sindoor was concerned. Especially our air defense system was absolutely bang on. Anything would you would like to say on that?
Yeah, absolutely. I love that topic also, primarily because they are indigenous systems, both Akash Tir and Integrated Air Command and Control System. Akash Tir is with the Army, where they have it's like a air defense control and reporting center where they have all the radars picture that comes merged into one comprehensive picture and displayed on the screen as one. Otherwise, if you see any radar that is picking up the same target, it will come as two targets. Now it has to see how many radars are picking up that same target and visualize it that it is the same target and thereafter make it as one target. So it fuses that comprehensive picture and presents it. Not only does it do that, it also has an artificial intelligence system associated with it, which tells it which is the weapon system which is closest and optimal to utilize against this type of aerial threat, whether it's a drone, missile, or it is an aircraft. Now it is linked to integrated air command and control system. If let us say we had shot down their airborne early warning and control system by S-400, 300 kilometers inside Pakistan. So only weapon system that can take it on is S-400. So it is, see how it's beautifully merging. You know, the system of the army is merging with the Air Force air defense capability, and the Air Force is the responsible person for air defense of our country.
Thank you so much, Air Commodore Bhal. You spoke about so many things and so beautifully you explained us the docking system and how complex it is. And you simplified it and took the questions also. We are very thankful to you for this podcast. And I would like to say best wishes to the crew and Group Captain Shukla and also the entire crew. And they have a fruitful tenure as they go there.
Thank you, ma'am. And I
Thank you so
thank
much.
Claus. I thank the DG, who's always been a source of inspiration to me. I thank him wholeheartedly. And I thank our country. And I say only two things: Jai Hind, Jai Bharat.
Thank you so much. Thank you so much.